Hey, we're going to do our notes on the correlation coefficient. Move this out of the way. We are going to interpret slope and y-intercepts in context. And we're going to find and interpret our correlation coefficient. Now, I have been promising you that we would have a way to tell whether a correlation was strong or weak. And that is one of the jobs of the correlation coefficient. So we call the correlation coefficient the R value. And one of its jobs is to tell us whether our correlation is positive or negative. So if it's positive, we'll have, some upward trend like this in our data. And if the R value is negative, we would expect that we would have some kind of downward trend in the data. The second job of the R value, which will be particularly important, is to tell us the strength of the correlation. So we will be able to tell by the R value whether our correlation is strong, moderate, or weak. So here's how it works. Here is a number line, which is going to represent all the possible R values, okay? In the middle of the number line, where there's no correlation whatsoever, the R value is 0. Here, I'm going to write it like this. R equals 0, like that. Okay. When we have a perfect negative correlation, where our line of best fit or curve of best fit goes through our actual points, data points, then the R is -1. If we have a perfect positive correlation and our equation or curve of best fit is going through our data points, then our R is +1. So let's break up this and label the rest of the R values. We'll start over here on the left. The second tick is -0.8, and then -0.6, -0.4, -0.2, 0.2, 0.4, 0.6, and 0.8. Make my dots bigger. Sometimes you can't see the dots very good. Okay. So we will be able to tell, as soon as we have an R value, what type of correlation we have. So we're going to say that anything that is between -1 and -0.8, that is a strong negative correlation. So if you look down here at this example, this R equals -0.92, that would be very strong. It's like right there. The next one for R is -0.64. That would be moderate negative. So that would be right there. Okay, the next one, this one's tricky because a lot of kids will see the 8 and think, oh, that's strong. But this is 0.08. So if you think about rounding, this would be approximately R is -0.1, right? So that would be very, very weak. It's about right there. Okay, next up, we have a weak positive. So this is 0.003. That one is right about in there. Weak positive. And then an R equals 0.71. That would be between 0.6 and 0.8. A moderate positive. And then a 0.98. That's very, very strong. Almost perfect, but not quite. And then last, we have perfect positive, R equals 1. So that's an idea of what the coefficients are telling us about the strength of the correlation and the sign. So when we're talking about R values, R values go from -1 to +1, and in between. We cannot have an R value that's 3. Okay, 1 is the biggest, -1 is the lowest. We don't go to -5. It's not possible. Okay. Okay, next we're going to do some matching in Google Slides. So if you go to your Google Classroom, this should be assigned to you. It's like 9.3, example 1, and you will have access to it. So if you go to your Google Classroom, you'll be able to get this slide. And you can see that I have some scatter plots and then a number line with the R values, and we're going to move the scatter plots to their correct spots. Now, I like to start with the best correlations, the most strongest correlations, because those are the easiest to spot, and then I work my way to the middle, because when you get to the middle, it's kind of hard to tell. Okay, I see this one at the top left here. That one looks like perfect positive, so I'm going to move that over to R equals 1. Okay, then I have, this one looks like a very strong positive. I'm going to put that here for now. This one looks like a perfect negative. Here I see a strong negative. And then, whoops. Here I've got a weaker negative correlation. Okay, these are my last two. They kind of both look like no correlation, but when I put them side by side, this one looks like no correlation to me, and this one looks like very weak positive. So I'm going to put them in this order. Okay, so there's actually a second slide for exponentials. And you can match up the exponential ones. I'm not going to do that on the video because I'm pretty sure that you get the idea. So if you would do that on your own, that would be great. What am I doing? All right, I'm going back to the notes. So example 2, part A, says that we have to estimate the correlation coefficient. So we can see that there's a definite downward trend in this data, so our correlation coefficient will not be positive. So we can eliminate B, and we can eliminate 0 because it's obviously negative. Okay, now we've got either a moderate or a strong negative. And looking at how fluffy these points are, I would say that this is moderate. So I'm going to say moderate, negative as the correlation for the plot. Okay, part C says we have to use a ruler. So if you don't use a ruler on your test, you will lose points. So please circle that, put stars by it. Make sure you use a straight edge. You can use a folded piece of paper. You can use the fold as a straight edge. You can use your school ID, whatever you need to do if you don't have a ruler with you. So the rule for a line of best fit is that you want half of the data points above your best fit line and half below, and that it should go in the direction of your plot. So for example, I wouldn't make my best fit line go like this, even though there's half above and half below, because that's going in an opposite direction from my data. Instead, I want to make it go with my data and have half above and half below. That looks pretty good. Arrows on the end, and we're done. So make sure you use a ruler. Okay, example 3. The table below shows the daily high temperatures in degrees Fahrenheit and the number of frozen fruit bars sold on 5 randomly selected days. So we have to estimate the line of best fit using this data. So we're going to need the calculator. First thing I want you to do is clear the memory on your calculator, and we will put this data in. Let me find the numbers. Here we go. So the the temperature is going to be our x's, and those will go with list 1. And the frozen fruit bars will be the y's, and that goes in list 2. Okay. Go to stat. Oh, let's clear the memory. Second plus 712. Okay, memory cleared. Go to stat, edit, and I'm putting in the temperature, 54, 60, 68, 72, and 78. Okay, arrow to the right to list 2, 40, enter, 120, enter, 180, enter, 260, enter, 280, enter. Okay, so now I go back to stat. I'm done editing. I'm going to calculate my line of best fit. It says estimate the line of best fit on the directions. Here, I'll circle it for you. It says line. So I want number 4, linear regression. This one. Number 4, it looks like y equals mx plus b. Enter a bunch of times. It's telling me that my slope is 10.264, and my y-intercept is negative 505.551. So, write that down, my equation. Y equals 10.264x minus, I did not give myself enough room. Sorry, y equals 10.264x minus 505.551. Okay, now it says using the calculator, we have to calculate the correlation coefficient and round to the nearest thousandth. So this we have not done yet. Our calculator will actually find the correlation coefficient for us. So the steps we are going to take is to go to the catalog. So the catalog you can see is down here on the 0 button. It's right above the 0 button. So in order to get the blue catalog, we have to hit the blue second button first. So we're going to hit the second button, and then we're going to hit 0 and go to the catalog. Hold on, I think there's another way, and I just remembered it, and hold on. Okay, sorry, the way that I was telling you is not wrong. It's what we used to have to do with the old calculators, but last year we figured out a way to do it for the new calculators that is so much easier. So I'm going to show you the new easy way. So you go to mode. Mode is where we like change the language and put it in radian or degree mode, that fun stuff. So we go to second mode. No, not second. Gosh darn it. Okay, we just go to mode. Wow. Okay, it's fine. I'll be fine. We go to mode, and then you see down here where it says stat diagnostics. Okay, instead of being off, we want those on. So I'm going to arrow my cursor down there and go to the right and turn on my stat diagnostics. So arrow down. Okay, and then I move it to the right and I hit enter on. Now my stat diagnostics are on. So when you go to the hospital, like the doctor can diagnose you with an illness. Well, the calculator can diagnose the R value and tell you the correlation. So we're going to turn that on. Now we go back to stat. We go to calculate, and we're going to run linear regression again with the diagnostics on. So hit number 4. And you can see right here, it's telling me the R value. Okay, so we're going to round to the thousandths place. So it's going to be R equals 0.984 because the 9 tells the 3 to go to a 4. Okay, we don't use R squared because if you square a negative, like if I had an R value of like negative 0.9 and I square it, then I'm going to get a negative times a negative makes a positive. So R squared doesn't tell you anything about the sign of the correlation. It just tells you the strength. So we don't use R squared. Get rid of it. Okay, so R is 9.84. R equals what was it? 984. So next it says to describe the association. So we don't have a scatter plot to look at. We didn't plot our data. We don't have that. So all we have to look at is the R value of 9.84. And if we look back at the first side, 9.84 is about here. And that's a very strong positive correlation. So that's what we're going to pick. Strong, positive. Okay, we're going to state and explain the slope. So the M is 10.264, and we can write it over 1 so it looks like a fraction. Be careful here, the Y is the frozen fruit bars. So this is the bars. The 1 is the temperature. This is degrees. So what's happening is that the number of frozen fruit bars being sold is going to increase by 10.264 with every 1 degree the temperature goes up. Okay, so frozen fruit bars sold increases by 10.264 for every degree the temperature rises. That's it. Okay, now we're going to state and explain the y-intercept. Now, not from our data, okay, we're just looking at the equation of best fit. This is our B. So our y-intercept is 0, comma, negative 505.551. 0 is the temp, and negative 505.551 is the frozen fruit bars. Now this is a little bit ridiculous. Our model is predicting that when the temperature is 0 degrees Fahrenheit, we're going to sell negative 500 something fruit bars. That's ridiculous, okay? We're not going to sell negative fruit bars. But we have to write it anyway. So we're going to say the model predicts at 0 degrees Fahrenheit, negative 505.551 fruit bars will be sold. That's it. Okay, let's do another one. That one was so much fun. Let's do another. This one will go faster because now we know what we're doing. Okay. Scientists are studying the efficacy, that means like the effectiveness, of an antibiotic on a bacteria population. Here is their data, which shows the population of bacteria each hour after exposure to the antibiotic. So an antibiotic is supposed to kill bacteria. So we're expecting that after these bacteria are exposed, they will start dying and the population will decrease. So we have to use the calculator to find the exponential relationship. So this one, we're not doing line of best fit, we're doing exponential. So that will be 0 exponential regression. Okay, let's do it. So we go to stat, we're going to edit, and I'm going to clear my lists because I've got new lists. Arrow up to list 2, clear, enter. Go to the right. Arrow up to list 1, clear, enter. Okay, so I'm going to put in 0, enter 1, enter 2, enter 3, enter. Go to the right. 6.7 million, 1.5 million, 0.3 million, and 0.08 million. Okay, go back to, our diagnostic tool is already on, but we're just going to remember how to do it. Okay, so we're going to go to mode, arrow down, and make sure that the stat diagnostics are on. Enter. And that will give us the R value that tells us the strength of our correlation. Oops, it's not what I wanted. Quit out of that. Go to stat, arrow over to calculate. We want 0 exponential regression. Okay, so we have a bunch of information here. We have not only our equation, but also the R value. I'm going to write this down real quick, and then I will write it on my notes. Okay, now I'm going to put that in the notes. My A value is my y-intercept. My B value is my common ratio. And my R isn't part of the equation, but it tells me about my correlation. Okay, so it was y equals 6.543. 6.543 times 0.08. 0.226 to the x. Then we found the R value. The R value was negative 0.999. This is extremely strong negative. Okay, that was the association. Okay, we're going to state and explain the y-intercept in context. So the y-intercept is, don't look at the table, use this one, the A value. It is 0, 6.543. So to label that, the 0 is the hours, and the 6.54 is the population of bacteria in millions. Bacteria in millions. So, model predicts. At 0 hours, the population of bacteria was 6.543 million. We know that that's not like what actually happened, because we can see right here it was 0.67. But based on the rest of the data, this is the prediction that came from the equation of best fit. Okay. Last, use the equation for the curve of best fit to predict the bacteria population 1 day after exposure. Now, be very careful. This says hours, and this says days. So you can't make the X 1. 1 day is 24 hours. So the X is 24 hours. So this is going to be a massive number. Okay, so y equals 6.543 times 0.226 to the 24th power. That's what we have to put in the calculator. So, I'm having a brain fart. 6.543 times 0.226 power caret 24. Now, this is scientific notation, which you probably haven't done in a minute. This e to the negative 15 means times 10 to the negative 15 power. That's what that means. Please write that down. So, if I have 2.0624 3115, what that means is that I have to move the decimal point over 15 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Whoops, I went too far. Oh, shoot. I was just on a roll. Okay, and for each of those spots where we didn't have anything, we add a 0. Okay. Now, a little bit about place value. Every 3, we put a comma. Okay, here's thousands. Here's millions. Here's billions. Here's trillions. So this is 206 trillion something bacteria. That's a lot of little critters. So now we just put that in a sentence. I can't look at these 2 screens at the same time. Wait, maybe I can. No, I can't. So you're just going to have to write this down, and we're going to, for part E, and I'm going to write my sentence on here, okay? So the sentence would be something like, model predicts, oops, this many bacteria after or at 24 hours. Now, some of you guys have figured out that you can also put this in y equals. So if you did that, let me show you what happens. Go to y equals. And we can put in our equation 6.543 times 0.226 power caret x. And then I can go to my table and I can find where the x is 24. Now, you can see that there's only so many places that your calculator has available to tell you this big number. So all it tells you is 2 times 10 to the negative 15. It doesn't tell you the rest of the information. So the most accurate way would be to put it in the other way. All right, that's all I got for you. Bye. Okay, every now and then you just have a massive brain fart, and I just had one. This 10 to it's negative 15 power. So everything I just told you, I did it backwards. The power is negative 15. So instead of going to the right 15, I said left, but then I went right like a Nimrod, right? It happens. I should have gone to the left. So, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 to the left. Gosh darn it. I'm not redoing the video. I'm just going to own that I messed up and you guys can laugh at me. It's fine. I've done worse. Okay, so this is going to actually be a small fraction of a bacterium. But yeah, sorry I messed up. Just fix the sentence, move the decimal point the other direction, you'll be fine. Sorry.